connection design. Clear? Lecture 5, which is connection design. Very important chapter of steel. Must listen it carefully. Okay, connection design. So in a connection, I will tell you strength of section are much higher than applied load, but if any structure fails, it will fail at connection only. So we need to provide a better connection for a good strength of section. Okay, so this is write down strength of, very important point, strength of section are much higher than applied load, but if any structure fail, it will fail at connection only. Clear? So it is two types of connection. First is dynamic connection and second is static connection. Okay, first one is dynamic connection. Dynamic connection is like a bolted connection, a riveted connection. These all are the dynamic connection. And what is static connection? Static connection is welded connection. Okay, or this is brittle in nature. So these connection are fail in dynamic loading. When dynamic loading comes, or we can say alternate stress produced in a member, tension or compression in a connection, so it is fail because static connection cannot prevent the alternate stress. Okay, so dynamic connection is better than static connection, we can say. Okay, because the dynamic connection is take care for the alternative stress produced by the tension or compression. So write down here, or we can say that fails in dynamic loading. Clear? Fail in alternate stress, either tension or compression. Clear? Okay. So in case of the bolted connection, what we need to check? We need to check the strength of the bolt and the strength of the joint. Clear? So write down bolted connection. Bolted connection, first is strength of bolt, and second one is what? Strength of joint. Clear all things? Okay. What is bolt? Let's say I will show you by the diagram. Let's see. Bolt. This is diagram of bolt. Here. Okay. This is head. This portion is shank. and this portion is threads. Clear? Let's say I'm cutting this section like this. Okay, this is x-axis. Okay, so what is the from the top, this portion is showing like this. Clear? So first, what is the nominal shank area? Area denoted by AS is what? Pi by 4 d square. You already know. And what is the d? D is the nominal diameter of shank of bolt. Clear? Second is, this is the shank and this is the thread portion. So threaded area, or we can say net tensile area, or we can say stress area, proof area. Clear? So what is it? Area net is equal to 0.78 pi by 4 d square. So now I will tell you the concept of force transmission using bolted connection. Okay, now let's say concept of force transmission using bolted connection. Clear? So let's say case first. I am showing the diagram behind. Clear? Let's say case first, when two plates are connected with two bolts in a row. Clear? Let's say this is one plate. Clear? And this is second plate combined together by a bolt. This is a bolt. Clear? This is nut and this is bolt. Clear? At bolt. Okay, so what is the, let's see P force is applying here. Clear? So this is the line of action of force of this P, and this is the line of action of force this P. So this is two force are applying in opposite direction, equal and opposite direction. Okay, then it having a plane, this plane, okay, by which it is chances to we can say what we can say shearing come in this bolt, and from where shearing comes, this is the shearing plane. This is the shearing plane. This is shearing plane. Okay, this portion is shearing plane, and number of shearing plane in this diagram is only one. This is one shearing plane, and this is what? This is the line of action of force. Clear? Let's see. Two bolt are from the top view. Top with this is the two bolt in same line. Okay, one bolt is here and one bolt is here. In top diagram, this is showing like this: one bolt and second bolt. if I am going to cut from here, then you can say free body diagram of this first part is this, second part is this. Okay, then first part force P is applying like this, and in second part, down part, this is the force P is like this. Okay, so this force is balanced by this force, and this force is balanced by this force. This is the free body diagram, and this is the shearing plane. Clear? Is it clear or not? Okay, so what is the shearing strength of bolt? Shearing strength of bolt. What? Firstly, number of is equal to number of shear plane. Remember this formula, into area of bolt into permissible shear strength. Clear? So this permissible shear strength is based on its ultimate strength. It is based on ultimate strength. Okay, because we need here the maximum strength, so we use here the ultimate strength. Okay, so write down what is the number of plane here. Number of plane is how many? 1. Here only one number of plane, into what is the area of bolt? Area of shank, this is shank portion, into permissible strength for shearing. I have already explained it to you. This is okay. Permissible stress for shear is Fy by 1.1 into root 3, but 1.1 for material, for yield strength. Okay, and 1.25 is for the ultimate strength, and 1.1 for the yield strength, but we are using here the ultimate strength. Okay, so we use here Fu divided by what? 1.25. Gamma MF is 1.25 because we need here the maximum strength. Okay, so it is 1.25 into root 3. Is it clear? Okay, now case second is when one plate connected with two plates. Okay, let's say when, write down, when one plate connected with two plates. Clear? Let's say this is a, let's see, one plate, force P is applying like this, and this is second plate, two plates on the top, cover plate. Okay, so this force P is balanced by these two. This is P by 2 and this is P by 2. Is it clear? So let's see, bolt is like this. Okay, so if we draw the free body diagram, then it is first shearing plane is this and second shearing plane is this. If we cut this, first portion, second portion and third portion, let's say first one is like this, having the force P by 2. Okay, and second portion is this, having the force P, and third portion is like this, having the force P by 2. So this P by 2 is balanced by this force, and this P is balanced by this P by 2 and this P by 2. Okay, and this P by 2 is balanced by this P by 2. Is it clear? This is the shearing plane. Clear or not? Okay. So what is the shear strength of bolt in this case? So shear strength of bolt is number of planes. What number of planes is 2? 1 and second is 2. Okay. Into area of cross section, yani area of the shank into what? Permissible strength. It based on ultimate strength. So you know it is Fu upon 1.25 and root 3. Why it is multiplied by root 3? Because mild steel is a ductile material and it is always fail in what? Shearing. So it needs the maximum value of PSF. So it is multiplied by root 3. Okay. Where? What is AS? Where we always use the AS is equal to area net, which is equal to 0.78 is pi by 4 d square. I will tell you why we use the AS as area net. See, I will tell you all the concept. Let's see. This is first plate, and as the previous diagram, this is two plates connected to the, this is force P, this is P by 2, this is P by 2. So this is the bolt comes here, and in half there is a threaded portion, and above is the shank area, and this is the threaded area. Clear? Okay. So we so what is the shear strength of the bolt? So it is for this portion, it is number of shearing plane is first for this. This is first threaded area, this is shank area. So number of shearing plane, area of the shank into permissible stress, Fu ultimate 1.25 into root 3, plus for the shank number of shear plane is 1 into area net